The difference between Earth and lunar gravity is one of the challenges space agencies and companies are trying to overcome in their quest to colonize the moon. Not an easy thing, given how one of the biggest hurdles in the way of overcoming this challenge is our inability to simulate lunar gravity for long periods of time. As it stands, whenever someone wants to mimic the moon's gravitational pull, they have to use a centrifuge drop tower, or parabolic flight. These methods are both expensive and they don't result in long times of moon gravity simulation, mere seconds of the special conditions, which most of the time are not enough. On Tuesday, February 4th, the world got a new tool when it comes to simulating lunar gravity thanks to the Blue Origin NS-29 mission, the 29th flight of the company's new Shepard spacecraft, and the 14th to carry payloads to the edge of space. NS-29, just like the previous missions, carried with it a wealth of experiments, a total of 30 payloads, in the skies above West Texas. It didn't last a lot longer than the preceding flights, just a little over 10 minutes, but 2 of those minutes were spent by parts of the spacecraft in lunar gravity conditions. The spacecraft managed to mimic the conditions on the moon by firing its reaction control system. That resulted in the new Shepard spinning up to around 11 revolutions per minute and generating about 1/6 Earth gravity at the midpoint of the crew capsule lockers. The 2-minute duration of the spin, the first time this particular spacecraft performed such a maneuver for so long, was used by NASA, which had a total of 17 technologies, instruments, and experiments on board, to test the effects of a reduced gravitational pull on some of the tech it plans on deploying to the moon in the near future. We're not told exactly how these tests went, but the general understanding is that the ship spinning managed to fulfill the requirements of Blue Origin's customers. Moreover, the flight opened the doors to testing further lunar technologies at a fraction of the cost of an actual moon mission. Aside from NASA, NS-29 flew payloads for Honeybee Robotics, aimed at finding ways to find, excavate, and process lunar regolith. Separately, thousands of postcards, part of the Blue Origin Postcards to Space program, took a trip just beyond our planet's atmosphere. Other experiments that were on board for the flight targeted dust mitigation, advanced habitation systems, sensors and instrumentation, small spacecraft technologies, and entry descent and landing technologies. Given how the mission just concluded, it's too early to say how any of these experiments went, but we'll keep an eye on developments and report back if we learn something of interest.